everyone, welcome back to VLSI for All. I'm Neeraj Cheriala, back with yet another expert talk on VLSI industry and career. And this time we have an honorable professor joining us. So he's ESTEVAO TEIXEIRA from University Federal de Juiz de Fora, often with an acronym UFJF. He has been at the university, teaching at the university for almost 12 years now. And he has also he's a graduate from the same university, UFJF. And surprisingly for all of you, this professor is from Brazil. And he is currently mainly working on open source VLSI software, a current relevant topic for all of us. Thank you, sir, for joining us with the session. We are very glad to have you with us.
Hello. I got the bachelor degree on electrical engineering at the Federal University of Juiz De Fora, or UFJF, in Brazil in 1998. The city of Juiz De Fora is near from the city of Rio de Janeiro, about 3 hours by bus. My course was a generalist electrical engineering course with some trends on power systems. There were courses related to analog, digital, and power electronics, but they were not the focus. However, I always liked the electronics and studied by myself some extra content that motivated me to move to this area. I achieved my master's degree on power electronics at the UFJF2 in 2002. When I decided to get a doctorate degree, I chose the area of microelectronics at the Federal University of Rio de Janeiro. I tell jokingly that I believe that lowering the voltages and currents, things could be easier, but it's completely wrong. Things in general get harder. So in 2010, I achieved the doctorate degree. Since 2003, I work as a professor and worked in some private universities and even at the Federal University of Juiz de Fora as a temporary professor during 2003, 2005. And in 2011, I joined the UFJF as a permanent professor. Since then, I have teaching electrical circuits, analog and digital electronics, electronics laboratory, and fundamentals of integrated circuits.
Yeah, thank you, sir. That was a good introduction. We got to know you a lot now. Now that you have told us about your background, your educational background. So since you are a permanent professor at the university, could you please let us know some of the advancements that are happening in electrical engineering that you are aware of?
I work with integrated circuits there. My research at the moment is by using open source tools to design integrated circuits with the launch of the free process design kits by Skywater and Global Foundries. I think that there is an increase of the demand to use of open source tools. In our university, we don't have a commercial license of tools because the integrated circuits design area is just starting now, and it's more interesting for us to work with the open source software.
So have you adopted this open source software into your labs at the university to teach your students? You are very experienced professor. How do you approach teaching complex electrical concepts to students at your university?
Yes, I guess the project-oriented learning is a good approach, although it's not the only one. But if you work with a team of students with some basic background, a specific project could lead them to divide the work into small parts that may be addressed individually in order to compose thereafter a more complex project devised to solve an engineering problem. There is not a need for a very complex problem to be solved. It, because if the project is too complex, the time could be a barrier, since the courses are usually programmed for one semester. In some cases, 2 semesters, depending upon the university. And the complex projects can take more time than this. So more simpler projects are recommended, unless the professor can accompany the students for more time. So I think a good strategy is the project-oriented learning.
Got it. So you say that the best strategy that at least you can think of is project-oriented learning, and that makes students get involved in the concepts as well. Yeah. Thank you
Yes.
for that. Yeah. So moving on to the next question. So can you share some of your research work in the field of electrical engineering?
In my doctorate, I worked with active pixel sensors, which are the basis of modern CMOS image sensor. And nowadays, I am studying the use of open source software for teaching and researching the integrated circuits, mostly applied to analog and mixed signal circuits. The research with the integrated circuit is just beginning in my institution, and at the moment, the use of open source tools is preferable than commercial tools. With the recent launch of the open source design kits by Foundries Skywater and Global Foundries in partnership with Google, the use of open source tools has been gaining more interest in the world. And we are trying to accompany this, this trend.
Glad to know that you are pursuing research using open source tools as well, promoting open source VLSI. So how do you think electrical engineering will change in the next decade, and what impact will it have on the society?
Today is common to discuss about the artificial intelligence and how it can change the society. But even artificial intelligence depends on microprocessors and more specifically on electronics that are a subset of the electrical engineering. So artificial intelligence, machine learning, data science, and other sciences depends on the electronics to continue their development. By the other hand, and the electronic device needs power. Okay, it needs power, and the efficient production of and processing of energy will be crucial to the modern society, not only for powering our high-tech equipment, but also for our health and well-being. So where energy is needed, the electrical engineering is so needed.
Yeah, that's very true. In fact, we are seeing that a lot of focus is being put on performance per watt, mainly for ML processing in this decade. And what you said is absolutely true. Yes, electronics, in fact, forms the base for any signs that would advance in the coming years? So the next question is, how important is hands-on experience in electrical engineering? And what kind of opportunities do you provide for your students in regard to this?
I think the laboratories should be introduced to the students since their first semesters of the engineering course. For electronics, it's very important to know how to handle an oscilloscope, a function generator, a logic analyzer, and the knowledge of designing PCB boards and other tools. For the microelectronics area, more specifically, it's also necessary the knowledge of circuit simulators and tools for layouts. There are free and open source tools available at the moment, and we use some of them in the integrated circuits course at undergraduate level. I am a laboratory enthusiast. I like to go with the students to laboratory and to sit with them to help to solve a problem, to test a circuits, and to expand their mind about the mounting, the assembling of an electronic circuit. I like laboratory so much, and I think opportunities for them to get into the laboratory is very interesting.
Exactly. So that's what most students think of it. They want to get this laboratory experience right from first semester, and you are spot on regarding that thing there. Thank you for that, sir. So, how do you see how do you see about the role of electrical engineering in addressing global challenges like the climate change?
I think electrical engineering can be a great partner in the fight against the climate change. For example, electric vehicles are gradually replacing fossil fuel-powered vehicles. And all the technology of electric vehicles is closely related to electrical engineering. The renewable energy, as photovoltaic or wind, must be conditioned in order to be injected into the grid. In Brazil, we have a great potential of wind energy. This means that systems are based on the solid state converters, which are in turn governed by a control system. The control system is in turn actually implemented using some kind of electronics, or analog or digital. This can show that several areas of electrical engineering can be involved in constructing a more sustainable world.
Yeah, that's great to hear about the role that electronics engineers play in climate change and renewable energy. So, what do you suggest or what do you advise students who are starting their career in electrical engineering?
First of all, of course, my advice is to study hard, because electrical engineering is plenty of complex concepts that have to be mastered. But I also recommend do not to restrict your course to the classroom boundaries. Making extracurricular activities will give you the insight and the perspicacity to be always up to date. Moreover, activities like internships, scientific initiation projects, or even a particular research project will give you some soft skills as the ability to teamwork and good written and oral communication skills. But the student must take care. You cannot abandon your regular course in favor of other activities because it's necessary to maintain the focus and to get graduated as soon as it is possible, in my opinion. So both things need to be shared. The formal the formal course, the regular course, and the extracurricular activities.
Yeah, that's actually very good tips for all of those who are watching this session. I guess student will inculcate some of these tips told by you who are watching this session. So, any tips or resources or book list or videos you would like to recommend to our audience who are inclined to pursue their masters in VLSI or core electrical background?
I like some classical books that are very interesting to me, like the Hazavi's Fundamentals of Microelectronics, the books of Professor Jacob Baker. I also like the books of Professor Franco Maloberti. These are books that I used and I still use for for study and for propose some projects. And but these works are mainly focused on analogy. But the VLSI student should be aware that digital electronics is a subset or a particular case of analog electronics with just two specific voltage levels of relevance. So understanding the fundamentals of CMOS circuits is relevant for both analog and digital designers. I like the site cmosedu.com of Professor Baker that has many interesting content about several tools, including the one that we use in our course, the electric VLSI design system, that is an open source tool. Many tutorial videos can be found there. As we are dealing with the open source tools, some channels for exchanging the experiences are very useful, like the Slack channel and Academy. So many YouTube channels like yours are very helpful, and the space here would be not sufficient to enumerate all of them. But certainly there are many YouTube channels very interesting with good quality material.
Yeah, we have noted down all the resources that you have just mentioned in your answer. And in fact, as you said, there are a lot of resources on YouTube. Uh, I guess we can share those other resources as well when we share this video with everyone. So thank you for pointing out all those resources, sir. So it was indeed great talking with you, sir. Thank you for all the answers that you have provided to our students in this session. So, like, when you look back, when you were young, what do you suggest young Stevo when he was just starting out his career in electrical engineering?
I thank you so much for this opportunity, and I hope we can join another interview, another talking in another moment. Thank you so much.
Thank you, sir. Thank you all for joining this session. We'll back with yet another experts talk on VLSI. we're looking forward to collaborate with ESTEVAO sir again for another moment. Thank you. Signing off.